Hi again. Now I want to talk about centripetal force and gravity. And in order to do so, I want us to consider a Hot Wheels car going through a vertical loop of track, which is a lot of fun. All right, so I've tried to draw it here. My car is just a circle. You know me. So here's my car. It's got some kind of speed, and it's going to go through the vertical loop like this. Okay? I want to focus in on the most interesting part of the track, which is when the car's at the very top of the loop. Okay? So at the top of the track, this is my car. There are two forces acting on it. There's gravity pulling it down. If the car is stuck to the track, there'll be a normal force pushing down because the car will be pushing up on the track. Track pushing down on the car. All right? Centripetal force is the net force. And remember, centripetal force is directed toward the center of the circle. And both of these guys, gravity and the normal force, are toward the center of the circle at the top of the track. Okay? So at the top of the track, the centripetal force is going to equal the gravitational force plus the normal force. Okay? There's a chance, though, that the normal force will be nothing, right? Maybe if this thing isn't going fast enough, it won't reach the top. The normal force will equal 0 somewhere before the top and the thing will fall. If the normal force is greater than or equal to 0 at the top, I should mention that. We are talking about the top, so hopefully that's understood. If the normal force is greater than or equal to 0 at the top, the car will successfully go through. Okay? If it equals exactly 0 at the top, it's going to have enough speed to keep going, and then the normal force will return. Okay? I want you to just think about that and make sure you agree with this statement here, because that leads the rest of the discussion and the type of questions we're going to do involving centripetal force and gravity. All right? Because the minimum speed that an object needs to have to go through a vertical loop will occur when the normal force is 0 at the top. And if this is 0, we just end up with this. Centripetal force equals gravitational force. Right? If the speed is any higher, you get a normal force at the top, which is great, which is good. All right? But the minimum speed is what I'm looking for here, will be when the normal force is 0 exactly at the top, and these two forces are equal to each other. Okay? So let's see what we can do with that. Okay, so if I make the centripetal force equal gravitational force, this becomes a simplified version of that. And this is just saying centripetal acceleration equals g. I think that makes sense, and we could frame our whole conversation around that. But I think the centripetal force conversation is a little easy to wrap our head around. Now I want to show you the kind of question I'll ask you to do. Okay, we're going to determine the minimum speed a Hot Wheels car must have to go through a vertical loop with a diameter of 30 centimeters. Okay, hopefully you notice right away I'm trying to trick you. I gave you a diameter instead of a radius. But anytime you see a vertical loop question, and you will see them, with minimum speed, this is what you do. Okay, and it simplifies down. I already showed you, but I'll go through the steps again. Okay, we're looking for V. R, of course, we have to divide by 2 is 15 centimeters, and you are going to want that in meters. So this actually is a really simple problem. We're just going to multiply those guys and take the square root. And I get an answer of 1.21 meters per second.